Hello everyone, in this video I'm going to walk you through the free response question 2 on the AP Precalculus Exam. Alright, now let's move on to question 8 right here. The table gives the number of cars in the parking lot at a local store when the store opens at 8 a.m., which means t equals 0. There were 4 cars in the parking lot. 5 hours later, t equals 5. There were 21 cars in the parking lot. 3 hours after that, t equals 8. 14 cars remain in the parking lot. So here's the table right here. The number of cars in the parking lot can be modeled by the quadratic function L, given by Lt equals AT squared plus BT plus C, where Lt is the number of cars in the parking lot t hours after the store opens. Now question AI. Use the given data to write 3 equations that can be used to find the values for constants A, B, C in the expression for Lt. Alright, now we're gonna go over here and this is the answer sheet for question 2. Now you need to write over here, right? First, you're gonna pick the points right here, right? So you have L0 equals A times 0 square plus B times 0 plus C, and then this one equals 4, right? This could be right here. Now second equation, L5 equals A times 5 altogether square plus B times 5 plus C, and this one equals 21, which is right here, right? The third equation, L8, is going to be A times 8 squared plus B times 8 plus C equals 14, which is this one right here, right? Now we're going to simplify this one so that it helps us to solve the A to I, right? So we have a system of 3 equations. The first one, 0 squared is going to be 0, right? So this one 0, this one 0, right? You only have C left, right? So C equals 4. Second one, 5 squared equals 25, so it could be 25A, right? Plus 5B plus C equals 21. The third one, 64, right? A plus 8B plus C equals 14, right? So we just leave it over there. Now we're going to move on to A to I. Now A to I say find the value of A, B, and C as decimal approximation. Alright, so we need to solve this one. So we have C already given, right? So C equals 4, right? Now I'll substitute 4 for C right here. So I have the system of 2 equations, 25A plus 5B. Now 4 right here, I subtract 4 both sides, so it's going to be 17, right? The second one, 64A plus 8B. Subtract 4 both sides, it's going to be 10, right? Now I look at this one right here, the coefficient in front of B is going to be 5 and 8, right? So on the first equation right here, I multiply both sides by 8, right? Second equation right here, multiply both sides by 5, right? So I have new system of equation, right? Now we're going to use elimination method, right? We just subtract this one vertically, right? So 320 subtract 200, it could be 128. This guy subtract this guy, it's going to be 0, right? 50 subtract 136, it's going to be negative 86, right? Now divide both sides by 120, so A equals negative 86 divided by 120, right? So it's going to be negative 86 divided by 120. It's going to be negative 43 over 60. So you're going to hit menu, number, convert to decimal, hit enter. It's going to be negative 0.716, right? Alright, now to solve for B, you're going to substitute this guy right here to the equation right here. Alright, so you have 200 times negative 86 over 120 plus 40b equals 136, right? Now you're going to simplify this one. So you have 40b equals 136 plus 200 times 86 over 120, right? And then b equals 136 plus 200 times 86 over 120 divided by 40, right? Now it's going to be 136 plus 200 times 86 divided by 120, close parenthesis, and all together divided by 40, right? Hit enter. It gives you exact value right here, right? Now you need to convert it to decimal, right? So hit menu, number, convert to decimal, hit enter. It's going to be 6.983, right? So it could be 6.983, right? So finally, you need to write the answer. It could be A equals negative 0.716, B equals 6.983, and C equals 4, right? Alright, now I'm going to show you how to use the calculator to check your work using the TI and SPI calculator, TI 84 plus CE calculator, and decimal graphing calculator, right? Now first, you're given the table right here. So you're going to print up the TI and SPI calculator. You need to go to the home screen, so hit on right here. Now, this one right here, as spreadsheet right here, right? And then the first column you need to name S value, right? The second column you need to name Y values, right? Now you just input the values for the table, right? So it should be 058. Now after that, you're going to move your cursor to the right of the Y column. Leave it over here. Hit menu, number 4 statistic right here, number 1 start calculation, and this is quadratic regression, right? So it should be number 6 right here, right? And then the first one right here, you would need to put S because this is S value, right? The second one right here should be Y, right? Now keep in mind, you store your equation as F1 because it's extremely important. You're going to use this one later to calculate the predicted values, right? And then you need to hit OK. Alright, let's give you the answer right here. A equals negative 0.716, B equals 6.983, and C equals 4, right? Now I'm going to use TI 84 plus CE calculator, right? You're going to hit start, edit, right? L1 right here, which means the S column, right? Hit click, go down. Go to the right, hit click, go down, right? Now you need to input the values for the table right here, right? Then you're going to hit start again, go to count, number 5 right here, quadratic regression, right? L1, which means the S value, L2, which means the Y value, right? Go to store regression right here. This is extremely important. You need to store your equation so that it helps you do the question later, right? So you're going to hit vars, Y vars, function y1, you store your equation as y1, right? So you're gonna go to calculate right here, hit enter, it's gonna be right here. Now what if we're gonna use dash mode, right? So you're gonna hit the plus sign right here, right, add table right here, right? So as value right here, you need to input the values for the table, right? 058, right? Alright, so after you finish inputting the table, you're gonna hit the dot right here, add regression right here, right? So you're gonna pick the quadratic regression. It's gonna be this guy right here, right? So it's give you the answer right here, right? See that? Now let's move on to question B, I and B, 2I and B, 3I, right? Use the given data to find the average rate of change in the number of cars in the parking lot in cars per hour from t equal 5 to t equal 8, right? Express your answer as decimal approximation, right? Show the competition that leads to your answer. So keep that in mind, you need to show your work, right? So we're going to move on to BI right here, right? So you know that the average rate of change formula is given by this one. Alright, so the average rate of change is going to be L8 subtract L5 over 8 subtract 5, right? Because the interval is going to be 5 to 8, so keep that in mind. Now L8, we look at the table right here, 14, right? L5 is going to be 21, right? So it should be 14 subtract 21 over 8 subtract 5, right? Now 14 subtract 21 is going to be -7, right? Over 3, right? They want us to leave our answer in the decimal number, right? So you're going to bring up the calculator. You're going to hit Control I. Add calculator, right? -7 divided by 3 is going to be this one, right? Converted to decimal number, right? So menu number converted to decimal number. Hit enter. It's going to be -2.333, right? Now, don't forget to include, so you need to say the average rate of change is -2.333 cars per hour. Alright, let's move on to B2I. Use the average rate of change found in part I to estimate the number of cars in the parking lot at time t equals 7. Alright, so you would have to use the point slope form formula that you learned in algebra 1, right? Remember that y minus y1 equals m times s minus s1, right? Now you need to write a new equation, right? So y1 and s1 right here, you can pick any points right here, right? So I'm gonna pick this point right here. This is my s1 and this is my y1, right? So I substitute over here, so I have y minus 21 equals the rate of change. This is the slope, which means -2.333 right here, right? So you have -2.333 times s minus s1, which means 5, right? Remember that s1, y1, you're gonna pick the point 521. So keep that in mind. Now we need to estimate the number of cars in the parking lot at times t equals 7, right? Now in this situation, s should be t, so I'm gonna change it to t, right? Now since t equals 7, so I need to solve for y right here. So y of 7 equals -2.333 times 7 minus 5, and then I need to add 21 both sides, right? So I'm gonna bring up the calculator. is gonna be this one right here, 16.334, right? So it's gonna be 16.334 cos, right? Now, question B, 3i. The arbitrary change found in part 1 can be used to estimate the number of cars in the parking lot at time t hours for t greater than 8 hours, right? Will this estimate found using the arbitrary change be less than or greater than the number of cars predicted by the model L at time t hours for t greater than 8 hours, right? Explain your reasoning. Your explanation should include a reference to the graph of L, right? So we look at the dash mode right here. Now, in order to do this question, we need to graph these two guys on the dash mode, right? So the first one is to be right here. LT equals negative 0.716t squared plus 6.98t plus 4, right? The second one, it should be right here. Right? So when we graph it, it's gonna be like this. Now when t is greater than 8 hours, 8 right here, right? And you have the intersection points right here, right? The graph of the quadratic function is steeper than the linear function right here, which means the average rate of change of the quadratic function when t greater than 8 is decreasing or smaller than the average rate of change of the linear function right here, right? So to answer this question, we need to say the estimate made with the average rate of change will be greater than the number of cars predicted by the model LT, because the graph of LT is the quadratic function right here, concave down, which means the rate of change is decreasing and less than the rate of change of the linear function right here, right? Alright, let's move on to the next question, question C. The model L is appropriate model to make prediction about the number of cars in the parking lot if the predicted number of cars in the parking lot is at least 0. Based on this information, what is the largest value of t for which the model is appropriate? Alright, so basically, you just let the quadratic function equals 0 and you solve for t, right? So, go over here, you need to say LT equals 0, right? And then LT equals this one right here. Now, we're going to use calculator or decimal to solve this one, right? You need to find the 0, right? So when you graph this one on the calculator, which means the quadratic function right here, right? So I need to eliminate this one so that it's not going to confuse you, right? It's right here. So the largest value, it should be right here. This one is less than 0, so don't worry about this guy, right? The 0 right here. So it's going to be 10.29542, right? So you need to say t equals 10.295, right? And then you need to say the largest value should be t equals 10, right? Now if you use a calculator, you just hit Control I, hit add graphs right here, right? So you put the quadratic function. Now if you want to use calculator to find the value of t, right? So you're going to bring up the calculator you did before right here. So you're going to hit graph. It's right here. Because the calculator stored the equation before, right? Now you need to adjust the window. The window should be negative 10, 15, and this one is negative 20 and 20, right? Hit graph, right? It's much better right here. Now you need to find the value of t right here, right? So you need to hit second trace, hit 0 right here. Alright, you move your cursor to the left of 0, hit enter, you get the first line, right? Move your cursor to the right of 0, hit enter. And move your cursor to the middle, hit enter. It's going to be t equals 10.286 right here, right? So right here, I need to adjust this one. It's going to be 286, right? Now let's move on to the next question. Task model B. After deciding to get back into shape, Mr. Passwater began a fitness program designed to improve his performance in the 1-mile run. On the initial day on the fitness program, Mr. Passwater ran 1 mile to determine his baseline time. At that time, t equals 0, Mr. Passwater ran the 1 mile distance in 6:24 seconds. For the next several months, Mr. Passwater was evaluated at the end of each week. Mr. Passwater performed a 1 mile run and his times were recorded to track his improvement. After 20 weeks, which means t equals 20, Mr. Passwater ran the 1 mile run in 5:02 seconds. Mr. Passwater 1 mile run time can be modeled by the function R given by RT equals A plus B natural log of t plus 1, where RT is the time in seconds for week t, and t is the number of weeks since the initial day of the fitness program. Now question A, I, and A, 2I. Use the given data to write two equations that can be used to find the values for the constant A and B in the expression RT. And then 2I. Find the values for A and B as a decimal approximation. Alright, so we given the equation right here, and we have 2 points. The first one, t equals 0, 6:24 seconds, right? And second one, t equals 20, is going to be 5:02 seconds, right? You have equation RT equals A plus B natural log of t plus 1, right? So you need to write two equations, right? Now, this one represents RT, right? This one represents t. So keep that in mind. You have the first equation. It's going to be A plus B times natural log of 0 plus 1 equals 6:24. And second equation, A plus B natural log of 20 plus 1 equals 5:02, right? Now move on to A to I. We need to solve for A and B, right? So from the first equation right here, it's going to be A plus B natural log of 1, right? Because 0 plus 1 equals 1, right? Equals 6:24, right? Second equation, A plus B natural log of 21 equals 5:02, right? Now from the first equation, I know that natural log of 1 equals 0, right? So I can include A equals 6:24, right? I substitute 6:24 for A into the second equation. So I have 6:24 plus B natural log of 21 equals 5:02, right? Now I need to solve for B. So B equals 5:02 subtract 6:24 all together divided by natural log of 21, right? So it's going to be 5:02 minus 6:24 all together divided by natural log of 21, and I hit enter. It's going to be negative 40.071, right? So I have the equation R of t equals 624 minus 40.071 natural log of t plus 1, right? Now let's move on to B2I, and B3I. Use the given data to find the average rate of change in the amount of time it takes meter past water to run 1 mile in seconds per week from t equals 0 to t equals 20 weeks, right? So you have the average rate of change formula. It's going to be f of b minus f of a over b minus a, right? You have the interval from 0 to 20, right? Which means a equals 0, b equals 20, right? Average rate of change equals R20 subtract R0 over 20 subtract 0. When t equals 20, we got 502, right? And when t equals 0 right here, we got 624, right? So we can use this one, right? It's going to be 502 minus 624 over 20 subtract 0 equals 20, right? So it's going to be negative 122 divided by 20. So it's going to be negative 6.1, right? So you need to answer the average rate of change is negative 6.1 seconds per week, right? Now let's move on to B2I. Interpret the meaning of your answers from BI in the context of the problem, right? So you're gonna say, on average, the amount of time it takes meter past water to run 1 mile in seconds per week is decreasing by about 6.1 seconds per week from t equals 0 to t equals 20 weeks, right? Because the rate of change is negative, right? Now let's move on to question B3I. Consider the average rate of change of the function R from t equals 20 to t equals p weeks, where p greater than 20. At this average rate of change less than or greater than the average rate of change from t equals 0 to t equals 20 weeks found in I. Explain your reasoning. Your explanation should include a reference to the graph of R. Alright, so you look at this one right here. The one in question I is going to be right here, negative 6.1. Right? And the one from the function is going to be right here. RT equal this one, right? Now, we're going to graph this one on the decimals. Right? So if we graph this on the decimal, it's going to be right here, right? Now, when t is greater than 20, so we look at this one. This is 50 right here, right? Now, greater than 20 is going to be right here, right? So from here all the way to the right, right? Now you see that the function is concave up, right? And decreasing, right? So the average rate of change of the function R from t equal 20 to t equal p weeks are greater than the average rate of change from t equal 0 to t equal 20 weeks, because the function R is the logarithmic function, right? With b less than 0. The graph of R is concave up and decreasing. Therefore, the average rate of change in seconds per week are increasing, which means it's getting less negative, right? Over equivalent input value intervals as t increases. Alright, let's move on to question C. Mr. Pass water plans to continue with the fitness program until his 1 mile time reaches 450 seconds. Explain how this information can be used to determine the domain limitation for the model R. Alright, so basically you just let the function rt equals 450 seconds, right? To solve this one, you either use graphing calculator or you're gonna solve this one by hand. Now first I need to solve this one by hands, right? And then I'm gonna show you how to use graphing calculator, right? So I need to add this guy both sides and then subtract 450 both sides, right? So I have 40.071 natural log of t plus 1 equals 624 minus 450, right? And then 624 minus 450 is going to be 174, right? Now I need to divide both sides by 40.071, right? So it's going to be natural log of t plus 1 equals, now natural log is the same thing as log base e, right? And if you have log base a of b equals c, and then you draw the arrow like this, so you have b equals a power of c, right? So I have t plus 1 equals e power of 174 divided by 40.071, right? So I need to subtract 1 both sides, so t equals e raised to the 174 over 40.071 subtract 1, right? So I print up the calculator, raised to the 174 divided by 40.071, right? And then I need to subtract 1. So it's going to be 75.883, right? So t equals 75.883, right? Now the domain should be 0.75.883, right? Now we're going to use dash mode to do this one, right? So you just hit the second equation, y equals 450, and you find the intersection. It's going to be right here. So the intersection should be 77.883, right? It's going to be exactly this one, right? Now let's move on to the next question, task model C. A team of scientists began studying the population of the white-tailed deer in a large wooded area in 2005. In 27, t equal to, there were 31 white-tailed deer in the wooded area. In 2020, which means t equal 15, there were 136 white-tailed deer. The number of white-tailed deer in the wooded area can be modeled by the function d, given by dt equals a times b raised to the t, where dt is the number of white-tailed deer during year t, and t is the number of years since 2005. Now, use the given data to write two equations that can be used to find the values for the constant a, b in the expression for dt, and then find the values for a and b as a decimal approximation. Alright, so we have the equation right here, and we have the points, right? Now, t equal 2 is going to be 31, right? So the first point is going to be 2, 31, right? The second one, t equal 15, it's going to be 136, right? d of t equals a times b power of t, right? Now, you have the first equation, it's going to be t equal 2, so you have a times b power of 2 equals 31. The second equation, a times b power of 15 equals 136. Now, we're going to move on to a2i. We need to solve this one, right? So I need to rewrite this one again. A times b power of 2 equals 31. And a times b power of 15 equals 136, right? Now, in order to solve a system of two equations right here, you need to do division. A lot of students make mistake. They're going to do subtraction. That's not the case, right? You need to do division so that you're going to eliminate a, right? So I need to take the second equation, divide by the first equation. So I have a times b raised to the 15 divided by a times b squared equals 136 divided by 31, right? So I need to eliminate a and a right here, right? So I have b power 15 divided by b squared. You know the formula, a raised to the m divided by a raised to the n. It's going to be a raised to the m minus n. So keep this one in mind, alright? Alright, so it turns out to be b power 15 subtract 2 is going to be 13 equals 136 divided by 31. So now go ahead, raise to the power of 1 over 13 both sides, right? So I have b equals 136 over 31 raised to the 1 over 13, right? So I'm going to bring up the calculator. It's going to be 136 divided by 31, right? Altogether raised to the 1 over 13. So the answer should be 1.120, right? Now I substitute 1.120 back over here, right? So I have a times 1.120 square equals 31. So a equals 31 divided by 1.120 square, right? So I bring up the calculator. This is going to be right here, right? So I need to square this one, right? It's going to be right here. So I'm going to take 31 divided by this one, right? So I have 31 divided by the answer, right? Hit second, this one right here, and hit enter. It's going to be 24.692, right? And my equation should be dt equals 24.692 times 1.120 raised to the t. Alright, let's move on to the question B. Now, question B say, use the given data to find the average rate of change in the number of white-tailed deer in deer per year from t equal 2 to t equal 15, right? I need d 15 subtract d 2 over 15 subtract 2, right? Now I have two order pairs right here, right? 2, 31 and 15, 136, right? So I have 136 subtract 31 over 15 subtract 2, right? So it's going to be 105 over 13, right? Now we're going to bring up the calculator. 105 divided by 13. It's going to be 8.076, right? Now you need to answer the question. The average rate of change is 8.076 deer per year, right? Now let's move on to question B2I. Use the average rate of change found in part 1 to estimate the number of white-tailed deer in the wooded area for t equal 19 years. Alright, so you know that the point slope formula is going to be y minus y1 equals m times s minus s1, right? Now you need to pick the order pair. S1, Y1 is going to be given right here, right? So I'm going to pick 231, right? So it's going to be equals 231, right? Now the applicable change, which means M right here. So M in this situation, we got it from BI right here. It's going to be 8.076, right? So I have Y minus y1, which means minus 31 equals 8.076 times s minus s1, which means 2, right? Now I need to calculate y of 19 right here equals, then I'm going to bring up the calculator. I still use this information right here, right? So I need to multiply by 19 subtract 2 is going to be 17, right? And then I'm going to add 31. So the answer should be 168.307, right? So 168.307 years. Now let's move on to question B3. Consider the values that result from using the arbitrary change found in EI to estimate the number of white-tailed deer in the gooded area for time t equals p years, where 2 less than p less than 15, and this estimates less than or greater than the number of white-tailed deer predicted by the model D at time t equals p years. Explain your reasoning. Your explanation should include characteristics of the arbitrary change and a reference to the graph of D. Alright, so go ahead, graph the function dt. Alright, previously we got the function dt right here. Alright, so it's gonna be like this, right? Alright, so d of t is the exponential function, right? And you know that the arbitrary change from 2 to 15 is going to be somewhere right here, and it's going to be right here. 15 is going to be right here, right? So you're going to draw the secant line. Now you see that the estimate using the secant line right here, or the arbitrary change from 2 to 15 increase steady, right? While the exponential function is increasing faster than the secant line right here, because the exponential function right here is concave up, so the rate of change is increasing, right? So dt must be greater than dp, right? Now let's move on to question C. Now question C, for which value of t equals 8 or t equals 23 years should the team of scientists have more confidence in when using the model D? Give a reason for your answer in the context of the problem. Now look at this graph right here. We can conclude that the teams of scientists should have more confidence in t equals 8 because t equals 8 is within the interval of data 2 to 15, while t equals 23 is outside this interval, and we do not have any information about a change in the deer population outside the interval 2 to 15, right? Now let's move on to task model D. After Mr. Passwater missed a day of school, a rumor began to spread out that he had won the Powerball lottery and moved to Japan. Initially, 7 students knew about the rumor. They were the ones that started. After 2 hours, which means t equals 2, a total of 15 students heard the rumor. After 6 hours, t equals 6, 67 students heard the rumor, right? The number of students that heard the rumor can be modeled by the piecewise function R given by this one right here, where RT is the number of students that heard the rumor at time t hours since the rumor first began. Question 8I. Use the given data to write two equations that can be used to find the values for constant A and B in the expression RT. Question 8-2I. Find the values for A and B as decimal approximation. Alright, now we have 2 points. The first one is going to be 2, 15, right? And the second one is going to be 6, 67, right? Right here. And this guy right here, right? Now we're going to use the piecewise function to write 2 equations, and then we're going to solve for A and B, right? Now we have 2 equations right here. Which one we're going to plug this point in? Now we need to look at the value of t right here. So value of t equal 2. So this guy between 0 and 6, right? So we're going to use the first equation for this point, right? Now this guy is 6, which means greater than or equal to 6, right? We're going to use this guy for the second equation right here, right? So keep that in mind. Alright, so I'm going to go over here. So I'm going to write 2 equations. The first equation right here is actually 7 times 8, right? Because 2 divided by 2 is going to be 1 equals 15, right? And the second equation is going to be negative. So to solve this one, I need to divide both sides by 7, right? So A equals 15 divided by 7, right? 15 divided by 7. It's going to be 2.142, right? Now B equals 67 plus 13.29 divided by natural log of 6, right? So it's going to be 67 plus 13.29 all together divided by natural log of 6, right? Hit enter. The answer is 156.432, right? Now, question B, I, 2I, and 3I. Use the given data to find the average rate of change in the number of students that heard the rumor in students per hour from t equals 2 to t equals 6 hours. Express the answer as a decimal approximation. Show the competition that lead to your answer. Alright, so we just use the average rate of change formula, right? So we have the average rate of change formula is given by f of b minus f of a over b minus a, right? So in this situation, it could be r of 6 minus r of 2 over 6 minus 2, right? Now r of 6 given 2 coordinate points right here, right? So we need to copy them down over here, 2, 15, and 67, right? So r of 6 equals 67, right? Minus r of 2 is going to be 15 right here, right? Over 6 minus 2, right? So 67 subtract 15 is going to be 52 divided by 4. So it's going to be 13 students per hour, right? Alright, now question B2I. Interpret the meaning of your answers from part 1 in the context of the problem. Alright, so this guy means the number of students that heard the rumor is increasing because this is positive, right? On average, by 13 students per hour from t equals 2 to t equals 6 hours since the rumor began, right? Now, let's move on to question B3I. Consider the values that result from using the average rate of change found in part 1 to estimate the number of students that heard the rumor for times t equal p hours, where p from 2 to 6. Are these estimates less than or greater than the number of students predicted by the model or 4 times t equal p hours? Explain your reasoning. Your explanation should include characteristics of the average rate of change and a reference to the graph of R. Alright, so because the domain is from 2 to 6, right? So we look at the graph right here. We're going to use the first guys right here, right? The function of t equals 7 times a, but a equals 2.142, right? So it could be 2.142 raised to the 1/2 t, right? Now this is an exponential function with the common ratio right here greater than 1. So this is exponential growth function, right? So the function is concave up, right? So if we graph this one, it's going to be something like this. Alright, this one is the y-intercept 7 right here, right? Now t is from 2 to 6, right? Which means the average rate of change is going to be right here. So we're going to go back over here. We're going to say that the estimate will be greater than the number of students predicted by the model R of t, because R of t is concave up exponential function on the interval from 2 to 6, right? Alright, now let's move on to question C. The model R is valid for t from 0 to 12 hours. Explain how the range values of the function R should be limited by the context of the problem. Alright, so we see that the domain is going to be from 0 to 12. We look at the function right here. From 0 to 6 is going to be the exponential function. From t greater than or equal to 6 is going to be the logarithmic function, right? Now, for t greater than or equal to 6, the function of t is the logarithmic function that increases without bound as t increases without bound. And we look at this one right here, we see that the graph of logarithmic function is going to be like this, right? Or you can use dash mode to check it. It's going to be alright, it's going to be like this. So it's going to be similar to what I did right here, right? Now you need to say that for t greater than or equal to 6, the function rt is a logarithmic function that increases without bound, right? When s increases. And you need to calculate r of 12 equals negative 213.29 plus 156.432 times natural log of 12. Alright, so I'm going to print up the calculator. I need to calculate this one. It's going to be negative 213.29 plus 156.432 times natural log of 12. Close it, hit enter. The answer is roughly 175 students. So the number of students hearing the rumor is about it, right? Alright, let's move on to the next question. Model E. Overnight, a large snowstorm passes through Plug Town. Snow began falling at 12 a.m., which means t equals 0, and continued to fall until 6 a.m., which means t equals 6. Once the snow stopped falling, Mr. Passwater began shoveling the snow off of his driveway. By 9 a.m. t equals 9, only 25 cubic feet of snow remained on Mr. Passwater's driveway. The amount of snow on the Mr. Passwater driveway in cubic feet can be modeled by the continuous piecewise function as given by this guy right here. Alright, if t is from 0 to 6, it's going to be linear function. If t is greater than or equal to 6, it's going to be exponential function. Alright, where s of t is the amount of snow on the driveway in cubic feet at time t hours since the snow began at 12 a.m. Now, question A, I, and A, 2I. Use the given data to write two equations that can be used to find the values for the constant a and b in the expression s of t, and then find the values of a and b as decimal approximation. S of t is a continuous piecewise function. So first it's going to be linear like this, and then it's going to be exponential function. So right at t equals 6 right here, you just substitute 6 for t into the first equation. You need to solve for s of 6, and then substitute t equals 6 to the second equation, so that you're going to solve for a and b. Alright, so go over here. I have the first equation. It's going to be s of 9 equals 25, right? Now, so I have a times b power of 9 equals 25, right? This is my first equation. Now the second equation, I have s of 6. So I'm going to substitute 6 for t into the first equation. I have 70 times 6 is going to be 420. So I'm going to use this one to write the second equation, which is a times b power of 6 equals 420, right? So I have two equations right here and this guy right here. Now I need to use two equations right here to solve for a and b, right? Now I'm going to take the first equation divided by the second equation. So I have a times b power of 9 over a times b power of 6 equals 25 over 420, right? Now a and a cancel out, right? B power of 9 divided by b power of 6 is going to be b power of 3, right? Remember a power of m divided by a power of n is going to be a power of m minus n, so keep that in mind. So it's going to be 25 over 420, right? Now I need to solve for b, so I'm going to take this guy right to the 1/3 both sides, right? So I have b equals 25 over 420, right? Right to the 1/3. It's going to be 0.390, right? So 0.390. Now I need to substitute 0.39 for b into one of the equations right here. So I'm going to use the first one, right? A times b power of 9 equals 25, right? So I have a times 0.39 power of 9 equals 25. So a equals 25 divided by 0.39 power of 9, right? So the answer is 118,540.8, right? Now question B, I. Use the given data to find the apprecalculus change from t equals 6 to 9, right? So we have B, I right here. It's going to be s of 9 subtract s of 6 over 9 minus 6, right? S of 9, we got it, 25. S of 6 is going to be 420, right? Over 3, right? So it's going to be negative 395 over 3, right? Now we're going to use the calculator. Negative 395 divided by 3. It's going to be negative 131.666, right? Cubic feet per hour, right? B2I. Use the arbitrary of change found in part 1 to estimate the amount of snow on the driveway for t equals 7, right? Now, we're going to use the point slope formula. Y minus y1 equals m times s minus s1, right? So it's going to be y equals negative 131.666 right here, right? Negative 131.666 multiplied by s minus s1. I'm going to use the point 9 and 25, right? So it's going to be minus 9. And then you're going to add y1 both sides, right? y1 is going to be 25, right? This one is s1, y1. So keep that in mind. Alright, now y of 7 equals negative 131.666 times 7 minus 9 plus 25. Don't forget parentheses, so keep that in mind. Now we're going to bring up the calculator, so it can be this number right here. I just leave it over there, and I'm going to multiply by 7 minus 9, it could be negative 2, right? So multiply by negative 2. And then I'm going to add 25, right? So it's going to be 288.323, right? Alright, question B, 3i, right? Consider the arbitrary change of the function s from t equal 9 to t equal b, where p greater than 9. Are these arbitrary change less than or greater than the arbitrary change from t equals 6 to t equals 9, ours found in part 1. Alright, so basically in order to do this one, we need to sketch the graph, right? Now we're going to go back over here. We see that the equation should be a equal this one and b equal this one. So we have s of t equals 11854.0.8 times 0.39 raised to the t, right? This is the exponential function when t greater than equal to 6, right? Now the question asks us to determine if the arbitrary of change greater than or less than the arbitrary of change from t equals 6 to 9, right? Now we're going to wrap this one on the dash mode to see what happens, right? So we have, so it's going to be like this. And you see that this is the exponential decay function. Now I'm going to wrap the function over here. So it's going to be something like this. T equals 6, it's going to be right here, and t equals 9, it's going to be right here, right? So you see that the arbitrary of change is increasing because the function st right here is concave up, right? So you need to say the arbitrary of change of the function s from t equal 9 to t equal p hours greater than the arbitrary of change from t equal 6 to 9, right? Because the function s is an exponential function with b less than 1, right? So the function is decreasing but concave up. Therefore, the arbitrary of change in cubic feet per hour are increasing or getting less negative over equivalent input value intervals as the value of t increase, right? Now let's move on to question C. Mr. Passwater plans to shovel snow until there is no snow left remaining on his driveway. Explain how this information can be used to determine the domain limitation for the model S. Alright, Alright, so we look at this graph right here, we see that the function is decreasing and it's getting closer to the x-axis, which means s of t is getting closer to 0, right? So there is sometimes t when he will stop, which means s of t equals 0, right? Since s of t is a decreasing exponential function, so it's getting closer to 0, right? Now let's move on to the next question. Question F right here. A group of students started a petition online in an attempt to push the start of the school day back 1 hour. 3 days after the petition was posted online, which means T per 3, the petition has received 4,000 signatures. After 7 days online, which means T per 7, the petition has received 23,000 signatures. The number of signatures the online petition received can be modeled by the function s given by s of t equals a times b to the t, where s of t is the number of signatures in thousand after day t, and t is the number of days since the petition was posted online. Question AI. Use the given data to write two equations that can be used to find the values for constants a and b in the expression for s of t. And question A2i. Find the values for a and b as a decimal approximation. Alright, so we have the function s of t equals a times b to the t. And you have two order pair. The first one, t equals 3, is to be 4,000 signature. T equals 7 is to be 23,000 signature. Alright, now the unit is to be 1,000. Alright, so you just use 4 and 23 only. So we have the first order pair, it should be 3, 4. The second one should be 7, 23, right? And the equation right here, right? So we're gonna go over here. Now this one right here we have s of t equals a times b power of t, right? Now we have two equations. The first one is going to be a times b power of 3 equals 4, right? Second equation, a times b power of 7 equals 23, right? Alright, now we need to solve for a and b, right? So we're going to divide this equation by this equation, right? So we have a times b power of 7 over a times b power of 3 equals 23 over 4, right? So a and a cancel out. I have b power 7 divided by b power 3. It could be b power 4 equals 23 over 4, right? Now I need to raise to the power of 1 4 both sides, right? So it's going 1 over 4 right here. It's going to be 1 over 4. So I have b equals 23 over 4 raised to the 1 4, right? So I'm going to print up the calculator. It's going to be 23 over 4 raised to the 1 over 4, right? So it could be 1.548, right? Now after I have b, I substitute b into one of the equation right here, right? So I'm going to use the first equation right here. So I have a times 1.548 raised to the third equals 4, right? So it can be a equals 4 divided by 1.548 raised to the third, right? So it's gonna be this one right here. I need to raise to the power of 3, right? So raise to the power of 3 is gonna be this one, right? And then I need to take 4 divide by this one, right? So divide by second answer right here. Hit enter. This could be 1.077, right? So I have the equation. It's gonna be s of t equals a. It's gonna be 1.077 times b it's going to be 1.548 raised to the t, right? Now let's move on to question B, I, 2i, and 3i. Now question B right here, we need to find the average rate of change from 3 to 7, right? Alright, so we have s of 7 minus s of 3 over 7 minus 3, right? S of 7, we got it right here, 23. S of 3, we got it 4 right here, right? So we have 23 minus 4 over 7 minus 4 is going to be 4, right? So we have 19 over 4, right? So 19 over 4, if you divide it, it's going to be 4.75 thousand signature per day, right? Now question B2I. Use the average rate of change found in part 1 to estimate the number of signatures in thousand the online petition received after t equals 13 days, right? So we're going to write the linear function in the point slope form, right? So we have y minus y1 equals m times s minus s1, right? Now I'm going to pick the points 3, 4, right? So I'm going to substitute over here, it's going to be s1 and this is y1, right? So it's going to be y minus y1, which means for equal the rate of change is going to be 4.75 right here, times s minus s1, which means 3, right? Now I need to calculate y of 13, right? So it's going to be 4.75 times 13 subtract 3, and then I need to add 4 both sides, right? So it's going to be 4.75 times 10 plus 4, right? So it could be 47.5 plus 4, right? So it could be 51.5 thousand signatures, right? Now let's move on to question B3I. Consider the average rate of change of the function s from t equals 7 to t equals p, where p greater than 7. And this average rate of change less than or greater than the average rate of change from t equals 3 to t equals 7. Right? So basically, you just grab the exponential function and you will see it. Now, you look at the exponential function, it's going to be right here. Right? The common ratio right here is greater than 1, so this is exponential growth function, right? So if you grab it, it's going to be something like this. Right? And then you have t equals 3, it's going to be right here. T equals 7, it's going to be right here, right? So you just get the second line. It's going to be right here, right? Now, this is 7. This is 3. Now, if p greater than 7, which means p is somewhere right here, right? So, the second line becomes steeper, which means average rate of change is increasing. So, it's going to be greater than, right? So, you need to say the average rate of change of the function s from t equals 7 to t equals p are greater than the average rate of change from t equals 3 to t equals 7. Because the function s is an exponential growth function with b greater than 1, the graph of the function s is increasing and concave up. Therefore, the average rate of change in thousands of signatures per day are increasing over equivalent input value intervals as t increase. Alright, now let's move on to question C. For which t values where t equals 6 days or t equals 19 days should the student have more confidence in when using the model asked? Now we look at this one right here. We just calculate the average rate of change from t equals 3 to t equals 7, right? So t equals 6 between 3 and 7, right? So the student should have more confidence in T percent because T percent is within the interval of the data 3 to 7, while T for 19 is outside this interval, and we do not have any information about a change in number of signatures outside the interval T for 3 to T for 7. Alright, let's move on to the next question. Question G. After Mr. Passwater decides that he wants to get back to his glory days, he joins a gym and begins a workout program designed to increase his maximum bench press. After 2 weeks, which means T for 2, Mr. Passwater's maximum bench press was 230 pounds. After 9 weeks, T for 9, his maximum bench press was 270 pounds. Mr. Passwater's maximum bench press can be modeled by the function m, given by m of t equal a plus b natural log of t, where m of t is his maximum bench press in pounds after week t, and t is the number of weeks since he began the workout program. Now, question A, I. Use the given data to write 2 equations that can be used to find the values for constant a and b in the expression, and find the values of a and b as a decimal approximation. Alright, so we look at this one right here. We see that we have 2 order pairs, right? It's going to be 2 and 230, right? 2, 230, right? Second one is going to be 9, 270, right? And we have the equation right here, a plus b natural log of t, right? So we're going to write over here m of t equals a plus b times natural log of t, right? Now for the order pair 2, 230, so you have a plus b natural log of 2 equals 230, right? The second one is going to be 9 270, right? So we have a plus b natural log of 9 equals 270, right? Now we need to solve for a and b, right? So we're going to go over here. In order to do this one, you need to subtract this guy vertically. Keep in mind, when it comes to exponential function, you need to divide. When it comes to the logarithmic function, you need to do subtraction. So a subtract a is going to be 0, right? So I have b natural log of 2 subtract b natural log of 9 equals 230 subtract 270 is going to be negative 40, right? Now I'm going to factor b out, right? So I have b times natural log of 2 minus natural log of 9 equals negative 40, right? So b equals negative 40 divided by natural log of 2 minus natural log of 9, right? So I'm going to bring up the calculator. It's going to be 26.594, right? Now we're going to substitute 26.594 for b into one of the equation right here, right? So I'm going to pick this one right here. Alright, so I have a plus 26.594 natural log of 2 equals 230, right? So I have a equals 230 minus 26.594 times natural log of 2, right? Alright, I'm going to bring up the calculator. So it's going to be 11.566. Now you have equation m of t equals to 11.566 plus 26.594 natural log of t, right? Now let's move on to the next question, bi right here. Use the given data to find the apprecalculus change, right? From t equal to 9, right? So we're going to use the formula m of 9 minus m of 2 over 9 minus 2, right? M of 9 equal to 70, right? And M of 2 equal to 30 over 9 minus 2 is going to be 7. So it could be 40 over 7, right? So we're going to bring up the calculator. 40 divided by 7. So it could be 5.714, right? Now let's move on to B2I. Interpret the meaning of your answer from part 1 in the context of the problem. Alright, so part 1 right here. So you need to say, Mr. Passwater maximum bench press is increasing on average by 5.714 pounds per week from week 2 to week 9, right? Alright, now let's move on to question B3I. Let ET be the estimate of the Mr. Passwater maximum bench press in pounds after T weeks using the average rate of change found in part 1. It's known that E12 equals to 87.14. Compute the ratio of this estimate compared to values given by the model for M12. For t greater than 9, the ratios of the estimates will always be negative. Explain why this is true. Your explanation should include a reference to the graph of M. So first, we need to graph the function m of t, right? Now, we know that the function m of t is right here. This is logarithmic function, right? So it's going to be something like this. Alright. Now you can use dash mode to check your work. Alright, it's going to be like this, right? So it's exactly the same thing, right? We need to review the formula of the regional value, right? So we have regional equals actual value subtract the predicted value, right? So in order for you to memorize the formula, look at the letter right here, RAP, right? So if you have graph greater than 0, this one is underestimated. If graph less than 0, it's going to be overestimated. Alright. So we need to calculate M12. Ratio equals M12 subtract E12, right? So M12, we're going to use the function right here. Alright, so we substitute 12 for t, right? So it's going to be 211.566 plus 26.594 times natural log of 12, right? It's going to be 277.649, right? Subtract E12 is given right here, 287.14. Right? Now, you need to subtract this one by 287.14. It's going to be negative 9.49, right? Less than 0. It tells us that M12 is always less than E12, right? For t greater than 9, the ratio of the estimate will always be negative. Explain why this is true. Now we look at this one right here. We see that the natural logarithmic function is concave down, which means E of t always greater than M of t, or M of t minus E of t is less than 0, right? So we need to say, right, let's move on to question C. Mr. Passwater decides that he should use Model M to make prediction about his maximum bench press beyond 12 weeks, as long as the difference in predicted maximum bench press between Model M and Model E does not exceed 30 pounds. For how many weeks should Mr. Passwater use Model M? Give a reason for your answer. Alright, so what we need to do is to find the equation ET first, right? Using the arbitrary chain right here. Alright, so we have the point slope form formula is going to be y equals m times s minus s1 plus y1, right? Now, s1, y1, we can pick the point. It's going to be from here 9 to 70, right? So it's going to be 9, to 70, right? The arbitrary chain, we're going to got it right here, 5.714, right? So m equals 5.714, right? Now we substitute over here, y represent e of t, right? Equals 5.714 times s, which means t, right? Minus 9 plus 270, right? Now we're going to simplify this one, distribute this one, and simplify. So it's going to be 5.714 t. And then 5.714 times negative 9 at 270. So it turns out to be plus 218.61, right? Now, previously, we have the function mt right here, right? So we copy this one there. mt equals to 11.566 plus 26.59 for natural log of t, right? Now we go back over here. We need this guy right here, the difference in predicted maximum bench press between Model M and Model E does not exceed 30 pounds, right? So which means we want E of t minus M of t less than 30, right? So we have E of t, which means 5.714 t plus 218.61 subtract 211.566 and then subtract this one 26.594 natural log of t less than 30. Alright, so this one is the system of two equations. The first equation should be y equals this one right here. Alright, I copy over here. And the second equation should be y equals 30, right? So I'm going to graph these two guys on the same x and y coordinate planes, right? And I need to pick the value of t squared. The portion of the graph is below 30, right? So I'm going to go to that mode. I have two equations right here. Alright, so the graph should be right here. Now the intersection between two graphs right here is going to be 17 right here, right? So the portion below the y equals 30 is this guy right here, right? So it should be less than 17, right? Because if it's greater than 17, it's above the line equals 30, right? So we need to say that t less than 17.296 weeks, right? Now let's move on to the next one, the Model H. Marie Curie first discovered radium in 1898 after isolating pure radium. Curie was awarded her second Nobel Prize in 1911, becoming the first person in history to win two separate Nobel Prizes. A group of scientists began studying a particular symbol of a radium isotope called radium 224. After 2 days, which means T equal 2, there were 3.42 grams of radium 224 remaining in the sample. After 13 days, which means T equal 15, the sample contained 0.29 grams of radium 224. The amount of radium 224 remaining in the sample can be modeled by the function R given by R of t equals A times B raised to the t, where R of t is the amount of radium 224 in grams remaining after day t, and t is the number of days since the scientists began studying the radium 224 sample. Use the given data to write two equations that can be used to find the values for constant A and B in the expression RT. Find the values of A and B, right? So we look at this one, we have two order pairs. The first one is to be t equal 2 and it's going to be 3.42, right? Second one, t equal 15 and it's going to be 0.29. And the equation is going to be right here, right? So we're going to go over here, we write two equations. The first one is going to be R of 2 equals A B squared equals 3.42, right? Second one, R of 15 equals A times B power of 15 equals 0.29, right? Now, in order to solve for A and B, I need to divide, right? Keep in mind. So, I'm going to divide the bottom by the top, right? So, I have A, B power of 15 divided by A, B power of 2. The reason why, because I'm trying to get rid of the negative exponent, right? So it's going to be 0.29 divided by 3.42, right? So A and A cancel out. So I have B power of 13 equals 0.29 over 3.42. Alright, so I'm going to raise to the 113 both sides, right? So B equals, right, hit enter, the answer 0.827, right? 0.827, right? Now I substitute 0.827 into one of the equation right here, right? So I pick the first one, right? So I have A times 0.827 power of 2 equals 3.42. So A equals 3.42 divided by 0.827 squared, right? So it's going to be 0.999, right? Alright, so I have the equation. It's going to be R of t equals 4.999 times 0.827 raised to the t, right? Now question BI. We need to find the average rate of change, right? From here to here, right? So from 2 to 15, it's going to be R15 subtract R2 over 15 subtract 2. So it's going to be R15 is going to be right here, 0.29, right? Subtract 3.42. 0.29 subtract 3.42 over 13, right? So I'm going to bring up the calculator. I have 0.29 subtract 3.42. It's going to be negative 3.13 divided by 13. So it's going to be negative 0.24, right? Grams per day, right? Alright, question B. Should I use the average rate of change found in part A to estimate the amount of radium 224 in grams remaining in the sample after t equal 9, right? So basically, you need to write the point slope formula. So basically, you need to write the linear function in the point slope form, right? So we have y minus y1 equals m times s minus s1, right? Now, s1, y1, I'm going to pick the point 2, 3.42, right? And the average rate of change is going to be right here, right? So m equals negative 0.24, right? Now, this one right here is y equals negative 0.24 times s minus s1, which means 2, right? Plus y1 is going to be plus 3.42, right? Now this one is the function in terms of t, so I need to change t, right? We have y of 9 equals negative 0.24 times 9 minus 2 plus 3.42, right? So we're going to bring up the calculator. We have negative 0.24 right here already, right? We need to multiply by 9 minus 2 is going to be 7, right? And then we need to add 3.42, right? So the answer should be 1.734, right? So it will be 1.734 grams. Now let's move on to question B3I. If the model R was graphed in the xy plane using a semi-log plot, where the vertical axis is logarithmically scaled, would you expect the graph of R to appear linear, quadratic, exponential, or logarithmic? Explain your reasoning. Your explanation should include a reference to the graph of R and the properties of semi-log plots, where the vertical axis is logarithmically scaled. Now you learn in topic 2.15, since the function r is an exponential function, right? It's right here. Alright, so the graph of r will appear linear on the semi-log plot because r is an exponential function, and when the y-axis of a semi-log plot is logarithmically scaled, the data or the function that demonstrate exponential characteristic will appear linear. Alright, let's move on to question C. The lab equipment that is being used by the scientists is only able to detect the radium-224 in samples that are at least 0.05 grams. Explain how this information can be used to determine the domain limitation for the model R. We just look at the function RT and we let RT greater than or equal to 0.05, right? So RT right here. You need to divide both sides by 4.999, right? So it could be. Alright, so you're going to bring up the calculator. 0.05 divided by 4.999, right? It's going to be 0.01, right? So it could be 0.827 altogether rate about t greater than or equal to 0.01. Alright. So in order to solve for t, you need to take log base 0.827 both sides. Look at this one right here. You need to eliminate this one, right? So that you can bring t to the front, right? So I have log base 0.827 and the right hand side log base 0.827, right? And I need to rewrite this one 0.827, and then I need to bring t to the front, right? It's gonna be like this. You need to change the inequality symbol, so keep that in mind. 0.01. Now if you have a power of t greater than or equal to b, if a greater than 1, b greater than 0, then you have log base A of A raised to the T greater than log base A of B. Now if A greater than 0 less than 1 and B greater than 0, you have log base A of A raised to the T less than or equal to log base A of B. So keep that in mind. Alright, so this guy actually 1, right? So I have T less than equal to this one, right? So I'm going to print up the calculator math right here. Now I go down until I see log right here. Alright, 0.827. And then this one should be 0.01. Hit enter. The answer is 24.244, right? So T less than equal to 24.244. So the final answer must be 0 to 24.244, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.